Hello everybody, today we are going to start with phase diagram. So the purpose of this video is to introduce phase diagrams and some of the basic terminology used in the phase diagrams. Now, phase diagrams are one of the important tools in material science and they contain a vast amount of knowledge. Phase diagrams basically are the graphical representation of changes in state due to the variation in concentration and temperature, which enables the phase content of the alloy to be determined at any temperature and concentration. Now the words I'm using here in this definition of phase diagrams like concentration and the effect of temperature. Then I used composition. All these are the terminologies which I was talking about that we are going to see. Now coming to phase diagrams, which is also known as equilibrium diagrams or equilibrium phase diagrams. It is a plot of all temperature compositions which represents the relationship between phases in equilibrium in a system as a function of temperature, pressure and composition. Like for example, you can see here I'm showing you a diagram of iron which is representing on the temperature and pressure axis. Temperature on the y-axis I have represented here and pressure on the x-axis. So this diagram is showing you what I was talking about, the plot that all temperature compositions is based showing the stability of various phases. Now here, since it is a single component system, only iron we are using, we are not using composition axis here. We are just simply representing iron on temperature and pressure. That means everywhere iron is iron, no compositional changes there. These phase diagrams enables the phase contents of the alloy to be determined at any temperature and composition. The temperature is going to be on the vertical axis, that is the ordinate, and when we are going to use the composition, that we are going to place on the x-axis, that is the horizontal axis. Moreover, in these phase diagrams, the solid phases are represented by Greek letters, that is alpha, beta, gamma, delta, like this. Like for example, in this diagram you can see I have represented gaseous state of iron which is above 3000 degrees centigrade. Then I have represented liquid state, okay, which is above around 1539 is the liquid, is the melting point of iron, so it is above that temperature. Now if I'm going to represent the solid state in this phase diagram of iron, then I will take use of these Greek letters alpha, beta, gamma, delta. So here we are going to usually represent the solid phases of iron as alpha, which is lying here. Then we have delta represented over here and gamma, which is represented in this region between temperature ranges 910 to around 1400 degrees centigrade, and we have epsilon here. So this is how we used to represent solid phases inside these phase diagrams. So to summarize the definition of phase diagram, we can say that phase diagrams are the maps that give the relationship between phases in equilibrium in a system as a function of temperature, pressure and composition. An example of this you have just seen, the temperature axis and pressure axis we have seen, and these are the equilibrium phases which you can see on the phase diagram. Since we are using a single component, that is iron here, so we are not taking composition axis over here. Next we have to define the term system. So here we are using the term system. So system, as we have seen in thermodynamics, region under consideration, our study is focused, which is surrounded or separated with the help of boundaries, that we call system in thermodynamics. Similarly, here we have a body of engineering material under investigation. Like for example, just now we have seen a system of iron. You have seen the system which has different regions, and all the regions of study are separated by the boundaries. In the same way, we have system of water that we are going to see in a while. So system we can define the system as to introduce a little bit more about these phase diagram. I'm going to explain you a system of water. So in a system of water, for water we know the physical state of water. So we know water exists in three states, that is solid, liquid and gaseous state. Okay, so if we talk about these three states in this phase diagram of water or system of water, so first we are going to represent the axis. So I take this as pressure axis, which is represented in Pascal. I take this horizontal axis as temperature axis in degree Celsius. I'm taking it. Now think about this two axes and try to understand the things that when we have high temperature and low pressure, so the space of high temperature and low pressure is this space, right? At this high temperature and low pressure, water will exist as that. You have to think in which physical state water is going to exist in this high temperature and low pressure region. So that state is gaseous state. Now if talk about low temperature and high pressure region, low temperature and high pressure region, so this corresponds to a physical state of water that is known as solid state. And somewhere in between there is like moderate temperature up to moderate pressure. See this space, moderate temperature and moderate pressure, that is in between these two extreme conditions, we will find liquid state of water available in this. Right, now I'm going to separate these regions with the help of boundaries. So that boundary usually comes like this. So now this is a representation of system of water. Now this is a phase diagram, you can say, of water, or pressure temperature diagram for water. So now in this phase diagram you can see I have separated the regions clearly with the help of boundaries. Okay, you can see here in this diagram that this is a region which is representing solid. That means under these boundaries the whole region is going to be in solid state, means water will be in solid state. In this region you will find water in gaseous state. In this region you will find water in liquid state. So this is what physical state of water is represented by the help of phase diagram. And at that particular temperature and a particular pressure, what type of state, what physical state of water you are going to achieve. Like say for example 100 degrees centigrade. Okay, so say for example this is 100 degrees centigrade. We know at 100 degrees centigrade water boils. Okay, and say this is 1 atmospheric pressure, which is the normal atmospheric pressure. Okay, so 1 atmospheric pressure, which is equals to 101.325 kilopascal, just to remember. Okay, so at this temperature right now you are here in this phase diagram of water. So what do you think about this state? What is happening here? You are at the boundary. That means gas, just if you increase a little bit pressure, what is going to happen? You are going to enter, as you increase a little bit pressure, you are going to enter into this region. That means now you will find everything in the beaker as liquid. Okay, but at this location, if you are going to see at this location in the beaker, what you are going to find is gas will be there plus liquid will be there. That means at the boundary, on the boundary I'm talking about, I'm just zooming in. Okay, so if you go inside, you see this is happening inside the boundary. Means the boundary is having two phases. So in this, what you are finding that there is a transition from gaseous state to liquid state, but it is not completed here. It is the transition zone which I am showing you here in this way. In the same way, anywhere when you are going to cross the boundary, so at the crossing, at the boundary, you are going to find both the phases which are available on either side of the boundary in that boundary region. Okay, this region, if we talk about this region, this point, you can see at this point what is happening, which is around 01 degrees centigrade or 273.16 Kelvin. That is this is known as the triple point, and this is known as normal boiling, you can say, because it is at 1 atmospheric pressure, which is the normal atmospheric pressure. Okay, next we are going to see this. So triple point. Now at this point you can see liquid is here present, solid is present, and gases is present. If you see this point, if you zoom into this point, you will find in this point what is happening in this point is that you have liquid, some solid is there, and some gas is there. So at this particular point, that is the atmospheric pressure is somewhere around 0.006 atmospheric pressure, okay, and 0.01 degree centigrade, which is the triple point for water. Okay, only at this particular temperature and pressure you are going to find that all three phases coexist together. So this is known as triple point, right? So here, how many phases you can see at the same point? 3 phases. Okay, and on these lines you can find 2 phases, either solid liquid will be present, or solid gas will be present, or liquid gas will be present. Third point, this point you see at this point, what is happening, it is just a little behind this point, that is 0 degree centigrade. Okay, and it is the, you can call it, it is in normal condition, it is the normal freezing point. So this is normal freezing point, this is normal boiling point 100 degree, this is 0 degree centigrade, and this point is the triple point for water. So I'm just showing you a phase diagram for water, and in this phase diagram you can see, you can get an understanding about the physical state of the element of the material, like water here. So it can exist in 3 states. So all the 3 states you can see at particular temperature and pressure what physical state you are going to get, and in how many phases you are going to find at that particular pressure and temperature. So you can take any pressure and any temperature and you can locate yourself that what state you are going to achieve. So this is like one of the, using these or studying these phase diagrams, you can easily get the information about the material or present in the system. So this is also a unary phase diagram, because we are using only one component here. This is water. This system is whole made up of water. Solid, what is there in solid state? H2O in liquid state, H2O in gaseous state. Okay, H2O, what is H2O? H2O is the element which has made this system, right? The molecule of water, H2O. Okay, so the component is same in all the 3 states of physical states. The component is same, so they have different phases. One is in gaseous phase, another is in liquid phase, another is in solid phase.